Hello, in this video we will work on the chapter 2.2 tutorial, which is Cauchy Euler equation. Euler equation. So we will work on the tutorial questions. So let's start from the question 1, and within the question I will try to explain the concept itself. So in question 1 it says that 2x squared y double prime plus y is equal to 0. So first we need to write the auxiliary equation. So to write the auxiliary equation, first we need to understand the concept. So what is the difference between this topic and the previous one? This method and the previous one. So in this method, if we see that, let's say we have y double prime plus y prime plus y is equal to 0, then we have variables like a, b, c, constants, and we have variables x square, x, and nothing, like just 1 here. The difference here with the previous one is if you see a double prime, then there should be x squared in front. If it is just prime, it should be x. If it is just y, it should be 1. So like if we had y triple prime, the number in front should be x triple, like cubic x. Now after knowing this, we need to write the auxiliary equation. So how to write the auxiliary equation? Like previous one, we normally wrote m squared for y double prime plus m for y prime plus just like 1 for y, which is equal to 0. And here the only difference is we will write a here, but instead of b we will write b negative a here, and here we will just write c. So this is the way, very basic, very easy. Let's put it back in our question. I'll write our question much like a bit longer. So it was given, but there is definitely 1 0 which is multiplied by y prime, and there is 1 which is multiplied by 1 is equal to 0. So by looking at this question, we can see that a is equal to 2, b is equal to 0, and c is equal to 1. So how can we write the auxiliary equation? I'll just write a is 2 m squared plus b is 0, a is 2, so 0 negative 2, 0 negative 2 m plus c is 1, I just write 1 is equal to 0. So it will be 2m squared plus negative 2m plus 1 is equal to 0. So we need to find what is m. Again, you can find it by calculator or you can use your own method. So let's find what is m. Okay, so the roots for m1 and m2 are as follows: 0.5 plus 0.5i, and m2 is 0.5 negative 0.5i. So again, by looking at this question, we can see that discriminant is less than 0. It has complex roots. So because of that, this goes to case 3. So let's talk about the cases first. If we have case 1, what will happen? If we have case 2, what will happen? If we have case 3, what will happen? So if it is case 1, which means discriminant is bigger than 0, and it has 2 different real roots. If that is the case, the y will be equal to c1 x m1 plus c2 x m2. So that is the first case. In the second case, which is discriminant is equal to 0, it means that we have one root, or we can say we have 2 same roots which is real root. Then the y will be equal to c1 x m1 or m, I just write m, plus c2 x m ln x ln x. So let's go to the third case, case 3, which is discriminant is less than 0. Then for discriminant less than 0, we can say we have two roots which are complex numbers. Then from that root we can find alpha and beta. If our root is in form of alpha plus beta I, so by here we can find our root. And what will be the solution for the equation will be y is equal to x alpha multiplied by c1 cosine beta ln x plus c2 sine beta ln x. Just no, not too much place for it, right? Okay, cool. So that is basic formulas, but we need to remember them by heart. By looking at them, we need to know them. So let's go back to our question. Because we found two complex roots, which comes to case 3, so we need to determine first what is our alpha and what is our beta. So because we found m1 is equal to and m2 is equal to 0.5 plus 0.5i and m2 is 0.5 negative 0.5i, you can definitely determine your alpha and beta. So alpha is 0.5 and beta is 0.5. So that's it. When we do the calculation for y, so it will be x over alpha is 0.5 multiplied by c1 cosine beta is 0.5 ln x plus c2 sine 0.5 ln x, and that's all for question 1. So let me turn to question 2. Okay, in question 2 it tells t squared y double prime plus 2y is equal to 0. So again, you can see that it is Cauchy Euler equation. First of all, it is homogeneous because it is equal to 0. And second, because it is double prime, it has t square, and because it doesn't have any prime, there is no t. So as you can see here, there is no x but t here. So t is another variable used instead of x, definitely. We need to write the auxiliary equation. So first let's determine what is a. A is 1, as you can see, because there is 1 that we cannot see, and b is 0 because there is no y prime, and c is 2. By looking at this, we can write the auxiliary equation, which is am square. A is 1, so I just write m square plus b negative a, which is 0 negative 1 m plus c is 2 is equal to 0. So I just write it again, m square negative m plus 2, which is equal to 0. We can divide it by its parts, which is let's find its roots. Let's find its roots to be sure. Okay, so roots for m1 is equal to 0.5 plus under square root 7 over 2i, which is m2 is equal to 0.5 plus negative 7 over 2i. So by looking at here again, we can find alpha, which is 0.5, and beta, which is under square root 7 over 2. So definitely, because it has complex roots, this is case 3, and case 3 was y is equal to x over alpha, which is 0.5, c1 cosine beta, beta is this, and ln x plus c2 sine again square root 7 to ln x, and that's all for the question. Let's move on to question 3. Let me open question 3. So in question 3 it tells that x squared y double prime negative 3x y prime plus 13y is equal to 0. So again we need to determine what is a is 1, b is negative 3, and c is 13, as you can see. Again, we can tell that this is homogeneous because it is 0, and it is Cauchy Euler equation because the number in front of y double prime is x squared, and this is x in front of y prime, and there is no x, or yeah, just there is no x in front of y. So to do this, we need to write auxiliary equation, which is a, which means 1m squared plus b negative a negative 3 negative 1 m plus 13, which is equal to 0. I just write again m squared negative 4m plus 13 is equal to 0. So let me do the calculation first. I'll come back. Okay, so the answer for m1 is 2.3i, and for m2 2 negative 3i. So by looking at here, we can say alpha is 2 and beta is 3. Yes. So again, it is a third question already. This is case 3 because it has two complex roots which has I inside of it. So I will write y is equal to x over alpha, which is 2, multiplied by c1 cosine beta 3 ln x plus c2 sine 3 ln x, and that's all about it. Let's move on to question 4. What does it ask in question 4? Question 4 is a bit different from the previous ones. It has t multiplied by y double prime negative 4y prime negative 4 over t y is equal to 0. So let's check if it is Cauchy Euler equation. First of all, it is equal to 0, which means that it is homogeneous, but I can see that it is y double prime, but the one in front is not t squared but t, and here is not t, and it is divided by t. What can I do? What can we do? So if I multiply the whole thing by t, like both sides, it will become t squared y double prime negative 4t y prime negative 4y, which is equal to 0 again, because 0 multiplied by anything is 0. Now we can see that it is Cauchy Euler equation. So determine a, which is 1, b, which is negative 4, and c, which is negative 4 as well. And after knowing this, we can write the auxiliary equation, which is m squared plus negative 4 negative 1 m plus, or just write negative 4 is equal to 0, m squared negative 5m negative 4 is equal to 0. Okay, so we need to find the roots. What is m1 and what is m2? I'll come back. Okay, so for the roots, m1 is equal to 5 over 2 plus under square root 41 over 2i. For the other one, oh sorry, it is not, there is no I. For the m2 it is 5 over 2 plus negative under square root 41 over 2. So it shows that it has two different real roots, and they are 2, which should make it discriminant should be equal to 0. Let's check it for to be sure. So what was discriminant is equal to b squared negative 4ac. b is negative 5 squared negative 4 multiplied by a is 1, c is negative 4. So as we can see from here, 25 plus 16 is definitely bigger than 0, which means we have two real roots. Then we already have the answer, y is equal to, which is case 1, because it has two different real roots. So I'll just write c1 x over, what is m1? 5 plus 41 square root over 2 plus c2 x 5 negative 41 41 over 2. Yeah, that's all about this question. We've done it. Let's move on to the fifth question. In fifth question, it tells that x squared y double prime negative xy prime plus 10y is equal to 0, and it also tells that y1 is equal to 1 and y prime 1 is equal to 1. First, let's check this is homogeneous. It is Cauchy Euler equation. It's fine. We find a, which is 1, b, which is negative 1, c, which is 10. Let's write auxiliary equation, which is m square negative 2m. I just write from here negative 1 is negative 2m plus 10 is equal to 0. Okay, so what is m1 and m2? Let's find out. So for m1 it will become 1 plus 3i, for m2 it will become 1 negative 3i, and again this is case 3, and what will be our y will be equal to x over, let's find alpha. Alpha is 1 and beta is 3. So x alpha, which is 1, just we can just skip it without writing. C1 cosine beta 3 ln x plus C2 sine 3 ln x. Yeah, that's our equation. That's for sure. So, but there is one part which is, it says y1 is equal to 1. Let's put 1 for x and y for 1. So 1 is equal to 1 multiplied by C1 cosine 3 ln 1 plus C2 sine 3 ln 1. So from here I just go on. 1 is equal to 1 multiply, I don't write, just C1. Now we need to know ln 1, I just write it separately. ln 1 is equal to 0. ln 1 is equal to 0. That's because this part means that e over something is equal to 1. So that's definitely that e over 0 is 1. So from here we can just write that cosine 0 plus c2 sine 0 is equal to 1. So 1 is equal to, again, c1. What is cosine 0? Cosine 0 is 1 plus c2 sine 0 is 0. So this part goes and c1 is equal to 1. So we found c1. That's the good part. After we know c1, we need to move on to the second part. In the second part it says that y prime 1 is equal to 1, but we don't know what's y prime. So let's first find out what is y prime. To find out what is y prime, we need to write it separately. We need to find y prime. I just write y is equal to x multiplied by c1 multiplied by cosine 3 ln x plus x multiplied by c2 sine 3 ln x. So let's find out what is y prime. Because this is multiplication rule, how did we do the, like, a multiplied by b, like differentiation? We write a differentiate b plus a multiplied by b differentiate. So knowing this, I just erase it. Knowing this, we will just differentiate x multiplied by c1 cosine 3 ln x plus x multiplied by c1 multiplied by cosine 3 ln x, differentiate, again I add, plus x differentiate c2 sine 3 ln x, I continue, plus x multiplied by c2 multiplied by sine 3 ln x, differentiate. So let's go to the back. X differentiate is 1, so I can write c1 cosine 3 ln x plus x multiplied by c1 multiplied by, so the differentiative of cos is sine, so negative sine, sorry, so I'll just write negative sine 3 ln x, okay, multiplied by, again we need to find the differentiative of inside part, 3 ln x. So what is the differentiative of 3 ln x? It is 3 over x. I hope it is fine for you. Then we go to the second part, which is differentiative of x is just 1. I just write c2 sine 3 ln x plus x c2, again the differentiative of sine is cosine 3 ln x multiplied by 3 over x. So let us first like makes it a bit basic. c1 cosine 3 ln x plus this x and this x goes, so it will become 3c1, and this will become negative sine 3 ln x, and plus c2 sine 3 ln x, and again the x here and here will go. I'll just write negative, not negative, sorry, multiplied by 3c2 cosine 3 ln x. Let's move on. We already know what is y prime. So after we know what is y prime, the given y prime 1 is equal to 1. We put it inside, and it will become 1 is equal to c1 cosine 3 ln 1 negative 3c1 sine 3 ln 1 plus c2 sine 3 ln 1, and again, this is plus positive, plus 3c2 cosine 3 ln x. No, not ln 1, ln 1, sorry. So as we said before, ln 1 is 0, so 1 is equal to c1 cosine 0 negative 3 c1 sine 0 plus c2 sine 0 plus 3c2 cosine 0. And now we know that what is sine 0 is 0, it just goes away, and 1 is equal to c1 cosine 0 is 1, I don't write it, plus 3c2, which is cosine 0 also 1, I don't write it. We found what is c1 before, it was 1, so 1 is equal to 1 plus 3c2. So from here we find out that 3c2 is equal to 0 and c2 is equal to 0, and that's all. Actually we need to go back, and previously, if you remember, our equation was c1, and because it was a case, it was case, which case it was? Okay, this was case 3, and this was our equation, so I just write it back. Actually, let's write the answer from here. So y is equal to x multiplied by c1 is 1, so I just write cosine 3 ln x plus c2 is 0, so 0 multiply anything is 0, I don't write 0 here, that is just the answer. That's all for question 5. So the last question, sixth question, is almost the same as like this, just you can see that it is the same. So I don't want to keep the video so long, we will just finish here. If you really want to be explained the question 3, you can ask you can subscribe to our channel, or you can ask in a message, we will explain it. Thank you so much and have a good day.